Have you ever wondered how we know so much about living creatures that went extinct millions of years ago? Well, for the most part, we have fossils to thank. Fossils are physical pieces of evidence of plants and animals that lived in prehistoric times. But we shouldn't take fossils for granted, because the process of fossilization is actually a very rare event. Most things just completely rot away after they die, leaving behind nothing for us to study or display in museums. So, how does the process of fossilization work, and what can we learn about the way that fossils are expressed in rocks? Hi, my name is Fiona Anstey. I'm in the class of 2024, and this is From Burial to Beneski, How Living Creatures Become Fossilized. The study of fossilization, or how organic remains pass from the biosphere, the system of living things, to the lithosphere, the system of rocks, is called taphonomy. To demonstrate this process of fossilization, today we will be looking at the Stenomylus hitchcocki. The Stenomylus hitchcocki was a small camel native to what we now know as North America. This species was discovered and named by an Amherst professor and alum, Frederick Loomis. He named it after Edward Hitchcock, a very famous geologist and the third president of Amherst College. This is a truly remarkable specimen. First of all, it was found as a complete skeleton, which is extremely rare. Most of the time, fossils in the field are found incomplete, and museums will then piece together the bones of multiple different individuals to create a whole specimen. But in extraordinary circumstances, you can find a fully articulated skeleton like this. So, what are these extraordinary circumstances? And what does it mean to find a fully articulated skeleton? Well, it means that the body was covered in sediment very quickly after it died. This could be because the animal died next to a lake or a river that then flooded, depositing sediment on top of it and preserving it in the rock record. It also means that the bodily remains were not disturbed by other animals or destructive forces like water or wind. Even tectonic processes can disturb fossil remains. A fault can cut through fossils preserved in rock, cutting them in half and offsetting them. We have a wonderful example of this in the museum. So, most biological remains are disturbed by these kinds of factors, like animals and water and wind. And so bones in the field are found in a kind of messy, haphazard way. But this specimen, which is encased exactly as it was found by Loomis in the 1920s, has its skeletal structure completely intact. And the way that fossils are found in the field, like the arrangement of bones, can tell paleontologists a lot about what happened to that animal after it died. Now, let's take a moment to compare our beautifully preserved Stenomylus fossil to another Stenomylus fossil. When we compare these two samples, you can see that they clearly tell a different story. So what we're looking at here is a compilation of multiple Stenomylus fossils. Again, they've been displayed to show you exactly how they were found in the field. They haven't been fully removed from the rock that they were found in. So, why do these fossils look so different? What happened to them? After these critters died, their flesh was probably consumed by predators, and the rest decomposed, leaving the skeletons behind. The bones then got all mixed up as other animals disturbed them, walking over their remains. Clearly, they had no respect for the dead 30 million years ago. And then the bones got washed away into a nearby river system. Here, they were carried downstream and eventually deposited along with other river sediment. Over time, this river sediment lithified, or turned into rock under very high pressures, to form the sandstone in which these fossils were found. So we've learned that fossil remains can be disturbed after the organism's death by wind, water, and even other animals. But biological processes can also play a part in the way that skeletal remains are expressed in the rock. Take a look at the neck of this stenomylus. Notice how it's curved? It's got a bend in it. This is an example of post-mortem rigor, where the limbs stiffen after death. And here's another example of post-mortem rigor in the Archaeopteryx. Note the curved position of the neck. Fossils are extraordinary records of the past. Not only can they tell us about life forms that no longer exist, but they contain information about what happened to those life forms after they died. Each of these specimens is so unique and special, and each one tells its own story.